Continuing with 12.6, Potential Effects of Global Climate Change and Arctic Sea Ice Thickness. We are looking down on the North Pole. The norm for comparison is 1955 Arctic sea ice. We can see that in the 2000s, the ice is about 79% of the 1955 volume, and is predicted to be down to 54% of the 1955 volume by 2050s. With a decrease in sea ice, both in the Arctic and the Antarctic, the coastline becomes more vulnerable to erosion. Melting of permafrost is exacerbated as well with open sea, which also furthers coastal erosion. And release of methane that was trapped in the frozen ground adds to the greenhouse gases in the atmosphere. Yeah, not so good. The next images show a view down the Whychuk Glacier in Glacier Peak Wilderness, Washington, in 1973 as compared to a similar view as seen in 2006, where this branch of glacier retreated 1.9 kilometers, which is 1.2 miles. And here's glacial retreat of two other glaciers, Pastersee Glacier in Austria and the Portage Glacier, Alaska. All of these glaciers have also undergone glacial thinning as well as retreat, i.e. their volumes are much smaller now than in the recent historical past. Decreasing glaciers and sea ice is a positive feedback cycle. Snow and ice reflects radiation, keeping temperatures low. Melting exposes darker ground, absorbs radiation, increases temperature, which causes more melting, etc. So a melting glacier generally increases advance of glaciers down into warmer areas, lower elevation, which increases melting. It doesn't sound positive, but the cycle is reinforcing itself, which is what a positive feedback cycle means. Climate patterns are changing. One evidence of this happening is the increase in frequency and intensity of storms. This in turn increases landslides, coastal erosion, storm damage, drought, wildfires, etc. El Niño is a natural climatic event that changes climate patterns. It involves high surface temperatures in the eastern equatorial Pacific Ocean, causes droughts and high-intensity rainstorms in various places on Earth. Oscillations like this influence climate over a short period of time, more than human-caused global change. The image shows how a change in generally warmer waters causes a change in the location of dominant evaporation and precipitation. You also know that the change in warmer water also means a change in where deeper, cooler, more nutrient-rich water is upwelling, and so this also affects sea life and those dependent on sea life. Again, El Niño is a natural climatic event that changes climate patterns. Here are some general El Niño effects. We see the above normal seawater temperatures near the equator in the Pacific, marked in red. We see areas impacted by floods, marked in blue. And we see areas impacted by drought, marked in yellow-orange. These impacts are global in scale. We even are impacted here in Idaho. El Niño years, like the winter of 2015-2016, we should expect slightly warmer temperatures. Many changes in climate are important to agriculture. Things like rainfall patterns, soil moisture, etc. With global warming, northern Canada and eastern Europe may prove to be more productive, and lands closer to the equator, including large portions of the United States, become more arid. Sea level rise is another change that goes along with increased average temperatures and melting glaciers and sea ice. Global ocean temperature has increased to a depth of at least 3 kilometers since 1961. Oceans have absorbed about 4/5 of the heat added to climate system. Thank you, oceans. The oceans have also absorbed about 1/3 of carbon dioxide emissions, which has increased acidity of the oceans by about 30%. Thanks again, and sorry, coral. The image below shows how CO2 is absorbed by the ocean from the atmosphere. In the ocean, CO2 and water, H2O, combine to form carbonic acid, H2CO3. It's called an acid because it can and easily does lose its hydrogen, and lonely hydrogen ions lower the pH, i.e., increase the acidity of whatever solution it happens to be in this case, the ocean. And unfortunately, this acid dissolves carbonates, such as limestone, corals, and most shells. This makes it hard to live in the ocean if you are a coral or a shellfish, or rely on corals or shellfish. Near surface ocean temperatures have increased, and warming causes ocean water to expand, which contributes to sea level rising about 1.6 millimeters per year. In contrast, melting ice contributes about 1.5 millimeters per year to sea level rise. Some conclusions. Thermal expansion and melting glacial ice contribute significantly to the observed sea level rise since 1961. The difference between observed and estimated sea level rise is considerable, suggesting that additional research is needed. However, we do know the rates of thermal expansion and melting glacial ice are accelerating. For example, the Greenland ice sheet's contribution to sea level rise has increased about 4 times in recent decades. All this has put considerable stress on sea life. Polar bears and corals are just 2 examples. Estimates of sea level rise over the next century vary from 7 to 23 inches. This could cause significant environmental impacts, such as increased coastline erosion, making structures more vulnerable to waves, and cause a landward migration of existing estuaries, requiring beach maintenance or abandonment of human structures. Sea level rise is already a threat to some small islands in the tropical Pacific Ocean, such as the Maldives, and is also already a threat in Alaska, causing rapid erosion of coastline and melting of permafrost soils, which is exacerbated by the loss of protective summer sea ice. With an increase in temperature and evaporation, often accompanied by a decrease in precipitation, it should be no surprise that climate change is generally causing an increase in both the frequency and intensity of wildfires. Warming may lead to more drought and El Niño events, and both are related to wildfire events. Wildfire events will increase due to global warming. Wildfires are predicted to increase in both frequency and intensity. Climate change leads to changes in the biosphere, of course. As a reminder, an ecosystem is a community of species and their environment, including chemical and energy cycles. Warming changes ecosystems, which may lead to risk of regional extinction of species and shifts in the range of plants and animals. Examples include mosquitoes are moving to higher elevations, northward movement of butterflies in Europe and birds in the UK, expansion of subalpine forests and cascades, sea ice melting stresses seabirds, walruses, and polar bears, warming and ocean acidity in Florida Keys, bleaching coral reefs. The image to the right is a series of pictures of coral bleaching. First, 1996, healthy coral. Then, 1997, bleached coral. 2000 and 2005, dead and overgrown coral. Save the coral, save your vacation. Who wants to snorkel over dead and overgrown coral? So a little closer to home, our continent. Warming effects in North America. Precipitation in some regions is projected to be less frequent but more intense. The temperature of streams and rivers will likely increase. Wildfires will be more frequent and several to many species will be stressed out. If possible, they will move toward higher latitudes and higher altitudes, but sometimes that is not an option. Like trees, don't move very fast. Neither do corals. And this changes ecosystems, which will cause havoc for a while as each species strives to find its new niche. More warming effects in North America. Growing seasons will be lengthened with earlier spring and greater primary productivity. If we have enough water, that would be great. Rainfall and wind speed from hurricanes and other storms are likely to increase in some areas. Right, in general, more rainfall in the east, less rainfall in the west. So has there and will there be any adaptation of species to global warming? Well, plants and animals have shifted their ranges 6 kilometers or 3.8 miles per decade towards the poles. That's a lot for a snail. The spring is arriving earlier, about 2.3 days per decade, which means plants are blooming earlier, frogs are breeding earlier, and migrating birds are arriving earlier. Unfortunately, not everything has adapted to this earlier arrival yet, so some animals are coming too late for a critical food source, which also means too much of that food source is left behind. For example, the timing of mosquito hatching should soon be followed by dragonfly eating. But if the mosquitoes hatch early and the dragonflies are still on their normal schedule, darn it, lots of mosquitoes are left over. Tropical pathogens have moved up in latitude and elevation, affecting species that may not be adapted to them. Several extinctions due to warming may have already taken place. For example, 60 frog species in Costa Rica and a type of opossum in Queensland, Australia. Note, critically, our current extinction event rivals or perhaps surpasses the massive extinction event at the time the dinosaurs all died. How is this going to shake out in the new ecosystems that are formed? What will be our place? Models that try to evaluate evolutionary response now try to incorporate competition between species, migration of populations, and invasive pathogens. So here's the question. Given that we are aware of the extinction event happening right now, what can we do about it? One thing we could do is assist in species migration. But should we? What do you think? Write me an email if you'd like to share your thoughts.